The Saga is one of my favorite patterns. It's your best ally when you cannot rely on a single database transaction to ensure consistency across your services. But like any powerful tool, it comes with a cost. In this video, I'm going to break down the 3 expensive taxes you need to pay every time you use the Saga pattern, so you can decide if it's worth it for your project. If you want a refresher on the Saga, watch this video first. It's one of the most popular on my channel. Let's start. Chapter 1. The Observability Tax. The first and most immediate pain you'll feel is observability. In a monolith, if the request fails, you have a single call stack. In a Saga, that spans across multiple services or multiple threads. Debugging is very difficult, so you're forced up to pay the observability tax by implementing 3 key solutions. First, the correlation ID, and this is non-negotiable. We need to generate a unique ID as soon as we start processing a request, and then we need to pass this ID like a passport through every single API call and message payload that's part of our workflow. Second, distributed tracing. This is a bit like the GPS for our distributed transaction. Through OpenTelemetry and other observability solutions, we can stitch together the entire journey of our request into a single, unified view. It's very powerful, but it's a significant infrastructure and instrumentation cost. And third, we have structured logging. Our logs need to be machine readable, and every single log entry must include the correlation ID. And this allows us to query our logging platform and instantly see the logs from all services that participated in a particular Saga execution. So, this was tax number 1. Let's move into the next one. Chapter 2. The Idempotency Tax. So, now we can see our transaction. But what happens when a step fails? Maybe because of a network blip. The simple answer would be to retry, but we can't always do that. Imagine if the step is charging the customer's credit card. There would be the risk of double charging it, because we don't know if the first attempt succeeded or not. In this case, we need to pay the idempotency tax. An operation is idempotent if we can run it multiple times with the same result as running it just once. To make our steps safe to retry, we need to force idempotency. For API calls, the simple solution is to introduce an idempotency key. This is a key and identifier that is generated by the client and passed in the API request, usually as a header. The server then has to check, have I seen this key before? If it's new, it processes the request and stores the key with the result. So if the same key comes in again, it will skip processing and just return the result, so we can avoid double charging. We can use a similar approach also with events. In that case, we can store the event IDs. Chapter 3. The Confidence Tax. Now, we can see our workflow. We can retry its steps, but can we trust it? This leads us to the final and sometimes most expensive tax, which is the confidence tax. You can have 100% coverage in each of your services, but that gives you 0% confidence that the Saga is working as expected, because a Saga's core functionality relies on the integration of the various domains or services. So, how do we test that? We need to invest heavily in end-to-end testing. These tests are the only way to be sure that our entire Saga workflow, including the failure paths, works as expected. But end-to-end tests are slow, brittle. They require a good portion of our system, of our microservices, and sometimes it's not really possible to deploy everything on a single developer's machine. Because of this reason, they are incredibly expensive to build and maintain. And that was our final tax. Chapter 4. The final invoice. So let's recap. The Saga pattern is a way to achieve consistency across our services, but it's not a free gift. You pay the observability tax just to understand what your system is doing. You pay the idempotency tax to make it resilient to failure. And you pay the confidence tax to prove that it actually works. The key takeaway is this: Sagas don't eliminate complexity, they just shift it. They shift it from the database to your application, your infrastructure, your testing strategy, and your team's cognitive load. So, next time you are in an architecture meeting and discussing whether we should use Sagas or whether we should build a microservices system, ask yourself, do I really need it? Sometimes the answer is yes, and that's perfectly fine. Whenever I need to deal with Sagas in a distributed system, I use a solution like Temporal. If you don't know what it is, please watch this video. It's really good. I would also love to hear about your experience with this pattern, or maybe you just want to suggest me a topic for a future video, so use the comment section below. As always, like, subscribe, enable notification and share so that everyone can learn something new. Ciao!